This is Algebra lesson 6.2, substitution. Okay, we went over this just one time yesterday so you can see how to do this. So listen, here's the deal. I'm telling you right now that you probably would never, I know that right now you understand how to do the graphing, and it should make sense. It's where the two lines cross. That's going to be true no matter what. And you can always, if you had to, you could graph it and you could find the answer. It's just inaccurate. Even with using a ruler, it is inaccurate. Substitution is one of the other methods of solving a system of equations, two linear equations. There will be many different types or ways of solving linear equations, a system of linear equations. One method is substitution, like I showed you yesterday. Here's when you know that substitution is a viable option, is when I give you a system where it is, 2x plus y equals negative 8 and 3x minus 2y equals 10. This is a system that would be very conducive to using substitution. The reason why it would be conducive to using substitution is because one of the variables in one of the equations is alone. If you ever see one of the variables that is alone, at least one, if there's one, then substitution is a viable option for solving the system. Because what's going to happen is let's just pay attention to this, really, your eyes up here. You're going to solve for the variable, that could have been an x, right? It's a y. You're going to solve for that variable, and then you're going to plug in what that variable is equal to into this one down here. You're not going to plug in y down here, you're going to plug in what y is equal to in this guy. And then you're going to solve the equation, right? Find out what x is equal to, and then you're going to plug in x up here and find out what y is equal to. Does that make sense? It's really that straightforward. Now it's just a matter of doing it. Here's the deal. And doing this is this is where we are now at the top of the hill, right? We're going to be having to remember how to substitute properly and then do the distributive property. And then we're going to have to, plug that in and do it again with the other equation. And all of these things we're building up here. This is the mountain. Right? We're at a mountaintop here, and so let's do this. Let's solve for this. I don't even know if this one makes sense or not. We're gonna find out. Okay, so we're gonna solve for what? Y. We're gonna solve for that y on this top one. So can you do that in your head? Could you look at that and truly do that one in your head? You can go just y equals negative 2x minus 8. Do you agree? Okay, there's that. I'm gonna now take this and plug into y here, what y is equal to. So I'm going to take that and I'm going to go 3x minus 2 times negative 2x minus 8 equals 10. Do you see what I've done here? So we solve this now. Rainbow, rainbow. 3x plus 4x plus 16 equals 10. Do you agree? You see how I did the rainbow there? Okay. 7x plus 16 equals 10. Minus 16 would be 7x equals negative 6 divided by 7 divided by 7. You see how ugly this is? X equals negative 6/7. Could you actually grab that properly and put that exactly at negative 6/7? No way. Not possible. But now that is what x is equal to, negative 6/7. So now I got to go plug it into this guy right here. 2 times negative 6/7 plus y equals negative 8. 2 times negative 6/7 is negative 12/7 plus y equals negative 8. Oh boy, plus 12/7 plus 12/7. Do you see how this gets ugly, right? But you couldn't grab this. Y equals, what is negative 8 plus 12/7? That is negative 6 and 2/7. There's my spot right there. The answer would be negative 6/7 and negative 6 2/7. It's a mess, right? But that's how you do it. Now, I'll tell you that almost always, it's nowhere near this complicated. They're usually going to be whole numbers. Just so that you can know how to do this. And, sometimes they might get to 1/2 or 1/3, but they're usually going to be pretty round. They won't be like 6/7. Let me give you one. You guys try one. Here we go. X plus 2y equals 6, and 3x minus 4y equals 28. Here's the deal. Here's my strong suggestion to you. Give yourself plenty of room. Do not skimp on this. This should take roughly 1/2 of a page. There is a lot of work to be done here. Give yourself plenty of room. 2 parts. One, you have to recognize what method to use in this situation. With this one, you would use substitution. Why? Why would I use substitution? There's one variable that is alone, right? He does not have a number in front of him. Makes this easy. If there was a number in front of him, you wouldn't use substitution. You just wouldn't. So anyway, here we go. This is how you do it. Pay attention. Follow the logic here. He is alone. What if it would have been x plus y equals 8? Which one do you solve for? It doesn't matter. Do y'all follow that? It doesn't matter. You choose either one. Okay. It happens to be that this is the x. We're going to solve for him, which means I got to get him alone. I got to move the I can subtract 2y from both sides. Agreed? So x equals negative 2y plus 6. Did everybody get to that point? Seriously, like your paper, did everybody get to that point? You solve for x, and you move 2y to the other side. Okay. Now that I have that, I'm going to take what x is equal to and plug it into the x down here. Just plug it in parentheses, always. So that would be 3 times negative 2y plus 6 minus 4y equals 28. Did everybody get to that point? Raise your hand if you got to that point. Did you not get to that point? Okay, so are you following me though? Okay. Once I've done that, now I've given you, listen, back in chapter 4, we learned how to do this, right? We've learned how to deal with that. This is a complicated equation, but it's still something that we know how to do. We're going to rainbow. 3 times negative 2y is negative 6y. 3 times 6 is plus 18. Minus 4y equals 28. I have to simplify this. Negative 6y minus 4y is negative 10y, right? Plus 18 equals 28. Minus 18 minus 18, negative 10y equals 10. Divide by negative 10, divide by negative 10. Y equals negative 1. Agreed? Did everybody get y equals negative 1? No? Does it make sense what I'm doing here, though? I mean, I can't reteach how to do this. I can't. Right? As long as you understand that's what you're supposed to do. There's a lot of steps. There's a lot of negatives. If you drop a negative, you're host. Y is negative 1. Now that I've done that, I go plug in what y is equal to into the original x plus 2 times negative 1 equals 6. X minus 2 equals 6 plus 2 plus 2. Whoa. X equals, what is that? Did I make a mistake somewhere? Yeah, I did. I made a mistake. Hold on. What did I do wrong? So hold on. It is x minus 2 equals 6. Right. Plus 2, x equals 8. So that I have 8, negative 1. X is 8, y is negative 1. There they are. This is the point. If I was to graph this, that's the point that the two lines would cross. If you want, you can graph it to see if you're right. That's one way of checking. Another way of checking is to do this. Go plug in 8, negative 1 into both of those equations. Plug it into both. Let's try it. Let's just see. Let's get rid of everything else except our answer. Here's our answer. We're going to get rid of everything else. On your paper, you would not erase this. You would just find more room. And you'd plug in 8 and negative 1. 8 plus 2 times negative 1 equals 6. Is that true? What is 2 times negative 1? So what is 8 minus 2 equals 6? 6 equals 6. That's true for the top one. Does that mean it's true for the bottom one? If it's for sure true for the top one, does that make that true? No. Let's go plug it into the bottom one. 3 times 8 minus 4 times negative 1 equals 28. 3 times 8 is 24. Plus 4 equals 28. 28 equals 28. That is true. It's true for both. When I give you, if I on your test, if you don't check your work like this, then you're silly. You're just lazy. On your homework, if I give you like 10 of these, this might be a little too much to check your work. Unless you're a straight A student and really want to make sure you get it, then what would you do? You plug it in, check it on both. You understand what I'm saying? I expect the B- students to just hope that they got it right. But if you're an A student, I'm showing you the way to check your work. That is, you take whatever answer you got. You got 8 negative 1, cool. Go plug it into the top one, plug it into the bottom one, make sure it's true for both. If it's true for both, that is the point that it crosses, right? That's the spot. Did anybody get that? How many of you got that answer? Okay, let's try another one. Okay, what about this? X minus 3y equals negative 9, and I'm gonna move it. Hold on, so I have more room. X minus 3y equals negative 9, and 5x minus 2y equals 7. There's your system. Solve that using whatever method you want, I'll just say, but I can't imagine you'd want to do it, use substitution. Again, watch, so you learn. For real, you're totally paying attention here. Again, I know right now this seems redundant, but you need to understand. So when you look at this, you should recognize that you would use substitution here because of that lone x, right? Because that x is alone, substitution is the obvious choice. Here's the deal. This is what you do. We're going to solve for that x, this equation for that x. So let's do that. That means it's going to be x equals, what am I going to do? What am I going to do? I'm going to add 3y to both sides. Do you see that? You see I'm going to add 3y to both sides? So 3y minus 9. All I did was take this 3y and move it over here, adding 3y to both sides. Agreed? We're all following that? Okay. Now that I have this, I'm going to take what x is equal to and plug it into here. Right? Right? Okay. So let's do it. 5 times 3y minus 9 minus 2y equals 7. Do you notice that this and this are identical? Except this, instead of x, I have what x is equal to. Do you all see that? Right? I just substituted it. Now we do rainbow, rainbow. That's 15y minus 45 minus 2y equals 7. Right? 15y minus 2y is 13y minus 45 equals 7. Plus 45 plus 45. 13y equals, what's 7 plus, that's 52? 52. Divide by 13. Divide by 13. Y equals 4. This is what it equals, right? And this is where I'm telling you that you have to be meticulous because, yes, is this already pretty long? This is the beginning of this problem, right? This is just the very beginning of this problem, and now we have y equals 4. Now I take y equals 4, go up and plug it into the original, right? Plug it into the original. X minus 3 times 4 equals negative 9. X minus 12 equals negative 9 plus 12 plus 12. X equals 3. Okay, so I now have what I think is true. X is 3, Y is 4. Technically, you could give me this answer and hope that it's right. 3, 4. That's what we hope is right. For those of you who want to make sure you got it right, what do? Go check it by plugging it into which? Both. Right? Go plug it into both. Let's clear this up. Let's start erasing things. I think it's 3, 4. I don't know. Let's go see if that's true. You would not erase this on your paper. You would just move over somewhere else. I'm just out of room on mine. I think it's 3, 4. Let's plug it in. 3 minus 3 times 4 equals negative 9. 3 minus 12 equals negative 9. Negative 9 equals negative 9. Yeah, true. Okay, let's plug it into the bottom one. 5 times 3 minus 2 times 4 equals 7. 15 minus 8 equals 7. 7 equals 7. True. 3, 4 is the answer. That's long. And there's a ton of steps. If you were to actually count each step, I bet it's 40. You can't drop a negative. You can't skip a step. You got to do them all. How many of you got 3, 4? Good. Let's try it again. Okay, what happens if well, we'll do this one. We'll do another easy one. 4x plus 5. Oh, well, question? You have 6 minutes, don't you? Noon? Oh, so you're in good shape. Awesome. We don't have time to do another one. It's already 54. But no. We're not done. I'm not going to have you do another one of those. I'll show you this, though. What happens if it's like this? You just watch this one. 2x minus y equals 8, and y equals 2x minus 3. This one you can use substitution. What should you use to substitute here? What should you use? You could use x or y, the x in the top or y in the bottom. Why would you want to use the y in the bottom? Because it's already done, right? I'm going to solve for that y. Oh, wait, I'm already solved for that y. So I'm going to go up here and plug this into this. Agreed? So instead of this y, I'm going to put that. So I'm going to go 2x minus 2x minus 3 equals 8. Do you see what I did? Do you all see it? Right? There's a 1 there. Do you agree? There's a 1 here. So I have to do rainbow, rainbow. 2x minus 2x plus 3 equals 8. That means it is, ooh, look at this. That's a mess. That is 3 equals 8. Does 3 equal 8? No. So then what's the answer? There's no solution. They never touch, right? I don't even get to put x or y or there's nothing. I mean, I've already eliminated them. It just says 3 equals 8. That means that no matter what x and y is, these things are never going to touch. If you were to go up here and look at this, if this happens to you and you're like, this makes no sense, what could you do? What could you do? You could grab, but you don't even need to get to that point. What could you do? You solve and turn these things both into slope-intercept form and then look at it and go, oh, they're parallel. No solution. Does that make sense? That's how you would check this, is you'd go, wait a second, this doesn't make any sense. So you're going to turn that thing into, so you're going to subtract, you're going to go negative y equals negative 2x plus 8, flip everything, y equals 2x minus 8. I have this and I have this. Same slope, crossing at different places. No solution. Yes?
Would you be able to tell if the textbook already has 2x and y equals 2x? Would you be able to tell?
If you could do that, I would have needed to do the work. You know what I'm saying? Sure. If you could look at that and tell, then sure, you go, oh, there's no solution. Absolutely. And sometimes they'll go like this. I'm not done with you guys. If it's 4x minus 3y equals 1 and 6y minus 8x equals negative 2, this is an ugly one. Wow, they don't even, there's no, they haven't shown you guys how to do this one yet. I wonder why they would have you, why would they put that there if they haven't shown you how to do it? Oh, it's a mistake. I'll show you. This is for the future, right? It's for the future. One thing you do is you look at this equation, and you know what I see? I see that that's not reduced. I could divide both sides by 2 and get those numbers to be a lot simpler. If I divided this whole thing by 2, what if I did this? What if I took this equation right here and went, okay, 6y minus 8x equals negative 2, and I divided it by 2 and divided this by 2. What's that going to turn this into? That's going to change that to 3y minus 4x equals negative 1. Right? Now, I want you to look at this. What if I multiplied this whole thing by negative 1? Negative 3y plus 4x equals 1 is the same thing as 4x minus 3y equals 1, which is, the same number, the same equation. Since it's the same equation, what's the solution? An infinite number of solutions, right? They're the same line. You just need to be able to play with this. I wouldn't give you ones that were like this. That's a little confusing. But you need to be able to play with this and go, oh, yeah, I see. Oh, that makes sense. They're the same line. Yeah?
When you're dividing the negative 2 by 2, don't you have to, is negative 2 have to be divided by negative 2?
You can do whatever you want to both sides, right? It would have been easier if I divided both sides by negative 2, but you can do whatever you want to as long as you do both sides, right? All right. Let me see here. I think that we're, yeah. Okay, I'm going to give you the homework, which is page 345, 8 through 22 even. Page 345, 8 to 22 even, okay?